Hello everyone. In this video we will solve the problem you can see in the screen. So this one is a very important problem from electrostatics, and it is actually, you can see versions of these problems everywhere. It is asked in JEE Main, Advanced, versions of this, and even in NEET. So I once saw Imad sir from Physics Wala solve this problem in a NEET session once. So anyway, today we are going to solve this, and actually this problem is on the very basic concept of electrostatics, but it's a little calculative. It states that there are two small equally charged spheres. We will assume that the charge is Q, and each of mass m are suspended from the point. So let me construct the diagram. It will be something like this. So this is the ceiling, this is the vertical line, and this is one point, one charge, and here we have another charge. The distance between them is x, so this distance and this distance, wait a minute, so this is x by 2 and this is also x by 2. So the whole thing is x, and this vertical distance, the length of the x is very small compared to L, so we can say that this is L. This length should be ideally root over L square minus x square, x by 2 whole square, sorry, but as x is very much less than L, so we can say that this length is L. Okay, and now for these types of problems at equilibrium, we have a very general formula. You must have seen that formula somewhere at least. That thing is nothing but this. Tan theta is the ratio of Fe by Fg, where Fe is the electrostatic force acting between the two charges and Fg is the gravity. Okay, and how do we get this formula? So that's very trivial. You have to consider the tension in the two strings. So the T cos theta, if this is theta, and if you draw this here, so this will also be theta. So from here, the component of the vertical component of tension that will balance your gravity, T sin theta will be equal to mg, and mg means Fg, the gravity, and T cos theta, that will balance the electrostatic force. So if you divide the first one by the second one, you will get that tan theta is equal to, I made a mistake here. This will be, mg and Fe will be reversed. So this will balance the electrostatic force and this will balance the gravity. Okay, so now if you divide the both, you get the above formula. So anyway, let's solve this now. So here we have the velocity approach, v is equal to a by root over of x. Okay, so now what we can write tan theta? Here from geometry we can write that tan theta, that will be is equal to x by 2L. That's from the definition of tangent of an angle. Now let us write tan theta, let us write Fe by mg. So what is Fe here? The electrostatic force. Two charges are equal, both are Q. So this will be nothing but Q square divided by 4 pi epsilon naught into x square. Okay, this is your Fe, and the gravity stays mg, so there is no complaint about that. So now we will write Fe by mg is equal to tan theta, or in other words, Fe is equal to mg tan theta, or tan theta is equal to x by 12 So let's write this q square by 4 pi epsilon naught x squared. This is basically mgx by 2l. Okay, so q square, we may write this as 2 pi epsilon naught. I mean, we are just taking q squared on the left hand side, and the whole right hand side becomes this 2 pi epsilon naught mg x cube, and below it will be only L. So now we want dq by dt. So let's just differentiate this. So this side becomes 2 in 2q dq dt, and if we cut the 2 and 2, so they're gone. So only q dq by dt survives, q dq by dt, and this whole thing is constant. Just xq will be differentiated. So this will be 3 pi epsilon naught mg by L mg x square. I mean, this is 3x square, so 3 is here, and this will be dx dt. Okay, so and now what is dx by dt? So now let's take we want what? We want dq by dt, and this is basically the rate at which the charge leaks of the spheres. So dq by dt, you just take the charge over that side, 3 pi epsilon naught mg x square, and this is basically our v, dx by dt, that is our v, velocity of approach, and under it will be ql. So and now we have v. I mean, v is given in our problem. So what is v given as? V is given as a divided by root over of x. So we may write that, and if root over of a is on the numerator, so mga this, and we will divide this by just wait a minute. Okay, we will a by root over x, so this will be x to the power 3 by 2, and this will be ql. Now we have almost do have our answer. Just now we have to find the ratio x, this ratio x to the power 3 by 2 by q. So we have to report our answer independent of both x and q. So let's just calculate this. So we had, let me erase this. Previously we had q is equal to q square. I mean, I am just writing that again. Fe by mg is equal to tan theta. So q square by 4 pi epsilon naught. Let me just maximize the screen. Epsilon naught x square. This was your basically mgx by 2l. Okay, so q square, this is nothing but 2 pi epsilon naught x square, sorry, x cube divided by L. Hence the ratio, I mean, if we take root, so this is x to the power 3 by 2, and multiplied by this we will have 2 pi epsilon naught divided by L. Okay, so we have our ratio q by, sorry, we have to, what do we have to be, x. Okay, so this will just be reversed. So x to the power 3 by 2 divided by q, this will be nothing but L by 2 pi epsilon naught. And now when you substitute that value in the given expression, it will become dq by dt. I mean, we will just have our final answer if we substitute this. So 3a will be outside. Okay, and now we had there were 2 pi L by 2 pi epsilon naught. So the whole part will be gone under the root. So even mg will be inside the root too. Oh, I actually have ignored mg here. There should be, let me just write x cube into mg. So we will have an 2 pi epsilon naught mg here, and this will also be 2 pi epsilon naught mg. So anyways, so if we report the final answer, the whole part will be inside the root, and this will look like something like this: pi epsilon naught into mg divided by 2L, and that's basically our final answer. So charge leaks off at this rate. So actually problems using this formula right here, this is very important for from the view of JEE and NEET too. These types of questions are usually asked even NEET too. I mean, this was one a little calculated. It cannot be asked in NEET, but problems like this is very important in JEE Advanced. And the fact that these types have not been asked in 2022 and 23 makes it very important for 24 and 25. Okay. So just keep this formula in mind, and you will be very easily able to solve this type of problems. So I mean, nothing more to say in this video. This was a nice and I mean very popular problem for Irodov. It was a Irodov problem, but it is actually one of the problems that is very relevant for JEE. You won't find much of in Irodov that I mean much problems that are relevant for JEE, but this one was, and this is among the 5% which is very relevant for JEE. So I mean, I hope you understood the concept, how to solve this problem, and I hope that you will be able to solve these types in future if it appears in your paper or something. So that's it. I sign off here for this video. Thanks for watching, and we'll see you in the next video.